So you've had a look at what metamorphic rocks are and how they're made with heat and pressure, but have you given a thought to trying to then link them back to the rock that they came from, their parent rock? That's what we're going to be doing now. See, this is sandstone, and if you look all around the Glasshouse Mountains, there is an awful lot of sandstone around the mountains. So you've got the mountains like this, and there's sandstone all around here, like this. Okay, so there's sandstone around the Glasshouse Mountains. We know it's there, but we know that it's laid down through sediments because it's a sedimentary rock. Sandstone's parent is sand that's been cemented together. So what we have here is sandstone up close and personal. This here is a sandstone under the microscope so that you can see the crystals that are within it. This one here as well. And you can see that the grains don't grow into each other. You've actually got in between all of these even smaller grains that are holding the sandstone together as it's cemented in. Now, this sandstone, along with many others, surrounds our Glasshouse Mountains. In fact, this picture here and this picture here are ones I took of stones that I found on the path as I walked around the Glasshouse Mountains. So it's surrounded by it. But it's not the only stone we find there. You see, we also find, I'll scroll down here, quartzite. And again, I took this photo beside the Glasshouse Mountains. Now, quartzite is cooked sandstone, literally cooked sandstone. So you actually have the grains that we saw above there actually changing their crystals, and that actually grow into each other under high heat, and they actually start to fuse together in a way that they couldn't before. So this is what it used to look like, and this is what it looks like when you expose sandstone to heat, and it actually fuses the crystals together and makes quartzite. So quartzite is essentially cooked sandstone, and again you find this all the way around the Glasshouse Mountains. If I found the sandstone here, I think we found the sandstone somewhere up, the quartzite somewhere up there. Okay, so we've got quartzite and we've got sandstone around our Glasshouse Mountains. Now, this here is granite. Now, remember, granite is an intrusive igneous rock. Okay, in other words, it was made deep under earth. Okay, so you usually can't find it unless you go digging. Okay, and granite has lots and lots of crystals that are grown into one another. You can see these crystals here, literally, see? These guys are growing into one another because it was formed slowly over time. So that's granite, but if you put it under heat or pressure, it will actually turn into schist. Okay, so this used to be granite. The crystals in that, again, have realigned, interlinked even further so that they're much more closely linked and much harder to break. And if it's been under pressure as well as heat, you'll start to see these fine grains or lines that form in it, as you've learned, this foliation. So as soon as I see that, that tells me not only has it been under heat, but it's also been under pressure because of the foliation that I see in the schist. So its parent is granite. Now let's have another look. Here's another example, limestone. Now limestone is literally the remnants of dissolved shells and bones of fish and animals. So because of all the calcium that's in them, that's where it gets the calcium from, bones and shells. So we know that limestone, when it forms, you often get shells trapped in the limestone as it's falling, because as you've learnt before, limestone is basically the leftover salty sediments that crystallize when water evaporates and leaves it behind, and along with any other fossils and bodies that are there at the time. So there's limestone. You can cook limestone, and if you do, you end up with this beauty here, marble. It's made of exactly the same elements, but it's been allowed to change under heat and or pressure, and the crystals in the limestone, and I'll get you a look at the crystals here. See these crystals here? As the water evaporated, they just sort of had to form wherever they could, and they're not exactly grown well together. But when you cook them and put them under pressure, the crystals actually form into one another like this, perfectly interlinking. And it's this interlinking that you get in metamorphic rocks which makes them so strong. Okay, as long as they interlink really well, that increases their strength, as you learned in the previous videos. And that's marble. And that used to be bones and shells. Here's another one that you'll know very well, mudstone, shale. Okay, we have an awful lot of this around the place. This is just rock that's made out of compressed mud, okay? But it is quite useful and it can be quite strong. However, any kid knows from art class that if you cook mud or clay, you get something that's much harder. And this is exactly the same when it comes to shale and mudstone. If it's exposed to heat or pressure, it changes. So look at the crystals that are in the mudstone and the shale here. Look at how fine they are. They're just cemented together fragments. Put them under heat or pressure, and you get slate. Okay, now slate is a very hard stone. It's used an awful lot for building works. Okay, it's easily turned into these fine sheets like this. Okay, you can cleave it off. Okay, it's still made out of fine grains. You can still see here there's lots of fine grains in it, but it has been actually forced under heat or pressure to turn into slate. Okay, let's see if I have another example here. I do. This is one that goes even further. Okay, so last but not least, we have gneiss. Now, gneiss is a type of rock that's actually formed from other metamorphic rocks. So if you think about slate here, just because it's sitting in the ground and it's already been cooked doesn't mean it can't be cooked more. You think about a cake, you can cook it, but then you can cook it again. You'll turn it into charcoal after a while, but you can still cook something that has been cooked before, and that is what gneiss is. This is a metamorphic rock that's been cooked and pressured even further to make it even harder. So gneiss is a rock whose parent is other metamorphic rock. Okay? Parents are the metamorphic rocks.